All right, welcome back, generals, to another Let's Fix Generals 0 hour to make the best game ever, and we are still developing unassemblize. Last session, we did some more fixes for the multi-threading in the work queue. Okay, we need to wrap up the change. Talking just makes me cough all the time. It's not good. I think I need to talk through my teeth. Yeah. Talk through the teeth. Don't move the mouse much. Then I think it would be better. Yeah. Whatever I say won't be as clear, but does it really matter? I think it doesn't. Okay, so what do we want to do? I think I would like to preserve the single threadedness of work queue and have the thread pool optional, aka enabled by default, but still have the ability to turn it off. Okay. Okay, let's go to the runner. Okay. So I would say we do it like this. If thread pool is not null pointer, then we do this. By the way, we could also do call wait on this one directly, right? Dot wait, and then remove this here, like this. Oof. Oh, that's hard to read. Ugh. That formatting is wild. Well, let's keep it like this then. Okay. Else. Else. Huh, is this correct here then? No, it doesn't look correct. It should be K in this as well. Okay. Okay, and here we remove this. Here as well. Maybe we should also use K down here then. Okay. Okay. Then let's do the same for the work queue. So this should be pointer. Make this a pointer. We can make it null pointer by default. Let's make it explicit. It's a it's a this equals null pointer or this and that. Let's make it a const bool has pending tasks. Not has pending tasks. Okay. Then here we do if thread pool is not null pointer, then we do this. Otherwise, we do. Otherwise, we do. Touch task. Can we maybe put this here into another function? Can have a void work let's do command work or command work, I guess. Then and there we pass this one here. Maybe call it async command. Command work on commands. I can't decide what this should be called. Command work. Okay, and then here we do we take all this here. We put it in here. Then we take this command. There we go. And then we do command work std move wrapper commands. Then we delete all this, else command work std move commands. Maybe we put this here in another function as well. Has or has pending tasks. Const. Then we put this down here. And then this here. Return. Not as pending tasks. There we go. Let's put another private here. Okay, then let's go to here. Let's pass thread pool. Let's pass null pointer. Null pointer. Im GUI app. Also pass pointer. Null pointer. Let's make it also explicit. There we go. Then we go to main function. And we pass this get and this dot get. All right. Okay, and then here we say thread count 0. So if thread count is 0, okay, thread pool, okay, thread pool. Thread pool count. And then we say here if runner thread count is larger than 0, then we do this. We put this here. Okay. Okay, so now if we run this, then it all should run the classic way, right? Let's see. Yeah. All right, cool. Then I wonder if we should also try to simplify the logic in in runner. So here, thread pool. Let's search for all occurrences of this, which there are 8. Okay, for most of these it's pretty short. Here it's a little bit longer. I wonder if it makes sense to wrap this into another function. Maybe. And this one as well, maybe. Disassemble matched functions. Disassemble matched. Yeah. 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 We can do here. What we can do is we create another. Oops. We create a copy of this function. Disassemble matched function. And we put matched function. We call it matched. And then we put it here. There. No. And then we put name function pair. Matched functions. Matched functions. So if we do this here, name function pair, matched. This is matched functions. So it's name functions pair. So it looks like we would have to pass this here as well, which is kind of wild. Matched functions. Because of this. I see. Okay, then we pass this here. And this const. I'll put this here, const. Oh shit. That was wrong. So we put this guy here. And put it here. Oh shit, we also need a setup. Pill. Okay, let's pass a std array setup to setup pair. One. All right. Then we pass here. This is a matched function. Name functions pair. Matched functions and setup 0, setup 1. Then we do the same here. Jesus. Okay. And then maybe we simplify this as well here. To a static bool load source file for matched function. We give it the storage. Give it this here. And we give it matched function. Matched function. Right. All right. So we do a bool, success, true, return, success. Then we put this here, success. Then we do matched. Let's put this here, matched. And that works, yeah. Okay, and then we call here storage and named functions pair and matched. So we can remove this. Can remove that, and we can return this, and we can remove this, and here we do a success, this, and we do this and this. Okay. Then we go to main. We remove these two. And we run it. Let's see. Okay, that was pretty fast. Looks good. Okay, then let's make a test with the non-GUI version. So we start here without the GUI. We run it. Let's see what happens. Okay, it ran through. Okay, looks fine to me. And it also runs pretty fast. Yeah. Very fast. So fast, can't even see what's happening. No. Good, then let's delete this. And this. And this. We can probably also move this here in line. Move this. Mm-hmm. 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 Okay, let's see. So this is fine. This is fine as well. This is also fine. This is fine. 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 This is set here. This assert looks wrong. So if we would set this to 0, let's put a breakpoint here. Oh, what happened? Ah, the assert didn't hit because we didn't run debug. Right. Right. Okay, let's also enable GUI again. There we go. GUI. Thread count 4, 10. Okay, and here we override it to 0 and 0. That means it will not allocate. Okay, and now this assert should hit here, and it does. Okay, let's remove this assert. There we go. All right, so now it's running without the threads. Yeah. Mm-hmm. Oof, takes forever. Yeah. Okay, good. Then that is sorted. Then let's put this here. Okay, so we staged that. That looks good. This also looks good to me. Initialize and that. Okay, good. So runner. Forward declaration set thread pool. Looks good. Disassemble matched function. All right. This one here. Oh, this one is actually wrong, isn't it? This thread pool. Hold on. How did this actually work then, runner? Yeah. This one needs to be initialized to null pointer. How this was not asserting, I don't understand. Strange. Okay, so this looks good. This looks good. 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 All right. Good. Good. Okay. The work queue is the most complicated of this change. At least we got rid of the work queue commands. Quit. That's good. Okay, we added some 2 mutexes. Additional atomic. And here an additional one, we added the thread pool, has pending tasks, command work, commands. Maybe we should rename this to do work. How about that? Do work. We wouldn't need to take the lock in this instance here. std unique lock. Do we have some? Do we? Async workstates. Mutex. Logguard. What is the difference between logguard and unique log? Optionally locking. Huh? Yeah, what is the difference? Unique lock versus logguard. What is the difference? Conditional locking. How? Unique lock conditional. Conditional locking. How? Unique lock conditional locking. I don't see it. Ah. Logs takes. Log. 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 I see. Okay, so we can use conditional locking with a unique lock. So if I understand this correctly, then what we can do is and we say if let's do a bool multi-threaded. Well, let's multi-threaded. Okay. Well, let's call it pooled. And we say if pooled, then lock dot lock how do we create a unique lock without locking initially? Can we do that? Oh man. Let's ask our friend ChatGPT. Can we how can we use the std unique lock to lock conditionally first? Yes. How? Defer lock. Let's see. Defer locking. Should lock. Lock.lock. Aha. Okay, I didn't know that. That's cool. That's cool. Okay. Then we do this. Let's call lock take lock if if thread pool if thread pool will enqueue here. Take lock if thread pool will enqueue. Okay, and then here we call with do work false, and here is true. Okay, let's rename this to has callback. Has delayed command. Okay, let's run this. Okay, that took very long. What is the problem? Main 0. Let's do this. Compare. Okay, that was super fast. All right, let's see. Okay, so this is good. Mutex, yeah. All public functions are meant to be called from a single thread only. Okay. We didn't use it, so we removed it. Do work. Bool pooled. Has pending tasks. Yeah. How about we initialize this to null as well here, just for robustness sake. It's not really necessary, but I think that's a little bit more sane. All right. This looks good. Callback queue size 0. Good. Good. Assert not is busy. Busy equals true, and then it starts the thread. Assert busy. Signal quit and wake up the queue. Let's be a bit more specific here. Wake up the command queue. Wake up. Signal quit and wake up the command queue. Yeah. Quit is true. Auto command. Make unique work. Empty work. We don't need to pass this here. Thread detach. If wait. Busy wait. Because needs to call update. While it's busy. Update callbacks. All right. Callback queue size, okay. Namespace avoids immutable lambda, which is incompatible with submit task. Maybe this comment should be elsewhere. Maybe it should here. Cannot use mutable lambda. Cannot use mutable lambda. Or you say needs to allocate wrapper objects because it cannot use immutable lambda. Because the thread pool is incompatible with mutable lambda. Needs to allocate wrapper object because the thread pool is incompatible with mutable lambda. Yeah. Yeah, that's a bit unfortunate. It would be nice to just pass the object here. Let's just to verify, let's check this once more. So detach task, wrapper, let's say command equal std move command. And that does not work. Cannot convert. Argument 1. Then we make it mutable. And that won't compile either. Yeah. That's a shame. Well, then we delete it. There we go. Do work, delete, wrapper. Okay, command queue is empty and pending tasks are left. Well, let's say and tasks are pending and no tasks are pending. Okay. Then I think this is fine. Maybe we can put back the space here. And then we have this. So I take this to work. Okay. It looks very good, I would say. Let's do one more test. So this is compare. Chaos very fast. Compare. Also fast. Good. Then let's simulate the one without here. There we go. Compare. All right. Let's do a compare and then we press the X here. Okay. Okay, that worked. Let's do the one with the exit. So we do this and this. Compare file exit. Also works. Okay, cool. Then we say implement thread pools for runner and work queue. Implement thread pools for runner and work queue to speed up processing. Yeah, I think that's it. Yeah, I would say implementation in runner is very good. It's pretty straightforward. Work queue is a bit more complicated, but it's still reasonably straightforward. Well, it's a bit complicated, this stuff here now. It was a bit easier before, but I'm not even sure if it was correct before. This thread join, actually, yeah, before it probably worked. Yeah. I do wonder. Oh. I do wonder. Stop. Yeah, here we could also. Actually, no, this is also correct. So it wasn't working correctly before either, I would say. Right? Because of this here. Yeah. Signal quit and wake up the command queue. Busy wait. Call busy wait. update callbacks until until the thread has quit. Until all work is completed. Until all work is completed and the thread has quit. Yeah. Update callbacks until all work is completed and the thread has quit. Detach threads and wait and detach threads. Well, I think that doesn't need documentation. Maybe we say never does not join the thread and update callbacks until all work is completed and the thread has quit. Update callbacks. Maybe we should add a comment here. When calling stop with wait equals false, must keep calling update callbacks. Let's call caller must keep calling update callbacks if wait equals false. To properly shut down. It's busy. Yeah. Until is busy returns false. Okay, we never call this function here. Might as well just remove that. Let's add a comment here. Is busy. Returns true as long as the work queue is running. As long as the work queue thread is running and waiting or working on commands. Returns true as long as the work queue thread is running and waiting or working on commands. This is pull results manually. Update callbacks and delete commands. Pulse one result at a time. Optional. When pulse one result at a time manually, returns nothing if commands have callbacks. Okay. Let's put that back. All right. I added a bunch of comments. Okay, this comment has an error. Main runner work here is completed. Update callbacks until all work is completed and the thread has quit. There we go. Good. Implement thread pools for runner and work queue to speed up processing. All right. Good. Is there anything else we need to do? I don't think so. It seems to work well. It's fast. Yeah. Implement thread pools for runner and work queue to speed up processing. Okay, let's commit this guy. Work. Update callbacks. Isn't there a mistake here? So we move this thing into the callback queue here and not into the polling queue. But if it doesn't have a callback, then it's not adding it to the polling queue either. Right? Huh. I wonder if we should just remove the polling stuff, the polling queue, because we're not using it. Might as well just remove it then. But I guess you can do it in a follow-up. Right. I think this here, like we don't use it, so. Yeah, let's do it in the follow-up. Implement thread pools for runner and work queue to speed up processing. Okay. Let's commit that. There we go. Okay, next step. Let's remove the polling functionality. So we got this, the polling mutex, remove that. We remove this. We actually also don't use the context thingy here. So we remove this. And that's it. Let's call back. Where do we pass the results here? In queue. Results. Huh. It's kind of weird that we pass the results to the create function. Why do we do that? Try DQ. You know what? Before we delete all this stuff, how about we first comment it out? So we comment out this one here. This. This. That. 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 And that. And then, yeah, I'm curious. So in the callback, we also pass the results. And here we pass the result again. Why? What do we do with it in the create function? Here, create chain. Okay. So here we have results. Are we using it? No. Are we using it here? No. Okay, let's search for chain to last. Let's see. Are we using result here? No. Here? No. 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 We're never using it. That's funny. Yeah. Then the question is, why do we pass it? Why do we pass it if we never use it? Um, hmm. Hmm. Mm. I probably thought that it might be useful for some reason. Chain to last. Yeah. I think one of the problems is that we don't really know what the command before was, right? Or we don't care. And if we cared, would we have a guarantee that the command is what we expected it to be? I'm not sure. Maybe we never use it because it's useless information. No. Yeah, so we could remove it. I'm just thinking like, okay, is there ever a case where we would need that? Result. We're also not really using the return much, right? We're just returning null. Like, we are not really using it the way it was meant to be used. Yeah. Well, here we are returning something. Yeah. A rare occurrence. And here as well. Yeah. Result. Yeah. Here we pass a null result, essentially. Okay, so for starters, here we can put this revision descriptor. No. Mutable. It's funny, in our work queue we can use mutable lambdas, but in a thread pool we can't. Very strange. Very strange. Yeah. So in a callback, we certainly use the result. Also, I wonder, why do we pass it as non-const? Because we can steal from it. Like we can move things from it, for example. Yeah. Yeah. Chain. The delayed command is result. Dot command, next delayed command at the time of invocation. Yeah, so the question is, do we want to remove this or not, the results? I'm not sure. Results. Yeah, I don't know. I'm just afraid that maybe we need it in the future. And then we don't have it. I don't know. So far we didn't need it. I don't know. What is this here, by the way? Delete command. Delete commands. Contains a command. Command. Yeah, I don't know. I don't know. Commands. So here in the callback, one would have the opportunity to reset the result, and then it wouldn't call the next delayed command. Command has delayed command. Yeah, to be honest, I don't know what the result would be used for here in the next delayed command. We don't use it, so I would say we just remove it for simplicity's sake, right? So we take this, we remove it, and then we remove this one here. And this. And this. And that. And that. And that. Okay. Then we go to here, and we remove all this. That, and that, yeah. Okay. Let's see if that compiles. Yeah, it does. Okay, cool. Then let's see how that change looks. So we can remove the context now. Let's remove all this, that, and that. Remove all the garbage. Then here we need to update this text. Optional function to create and chain one new command. The function is invoked after the previous command has completed its work and has returned its results. The result is not. So we can remove these two nodes because they no longer apply. Let's see. So this looks a bit simpler. Here we can remove this. And we remove this function and this and this. Okay, this looks good. So here we remove the dummy result. That's good. That's good. Here we have some commented function. Let's remove that. Yep. And here. Okay, it's always good to delete code. Makes things a little bit simpler. Yeah, this looks good. This looks good. This as well. Good, good. Good, 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 good. Good. All right, cool. So let's see if that runs without errors. Check that and that. Let's do not these. Okay. Then we go here. Yeah. It's very fast. The processing of the function is so fast that we don't even see like the loading thingy up here. So fast. That's nice. Okay, cool. Okay, cool. Then we say remove unused polling queue and results in polling queue and results. Let's say and result argument in create function. Remove unused polling queue and result argument. Polling queue and result arguments in work queue class. Move unused polling queue and result arguments in work queue class. Yeah, I think that is fair. Okay, cool. Let's commit this. All right. Okay, then I think this also means we can go to GitHub. Actually, here we already have it open. And we can go to the pull requests. We can go here. Let's go to... Let's push this to the branch. And we say... this change has been obsoleted. Thread pools has been implemented. Thread pools have been implemented. Close with comments. Yeah. Okay. Good, then maybe we can look into the remainders here as well. Yeah. What's the time? 2 hours, yeah. Okay, so... yeah. Yeah, I'm quite happy with the command queue, work queue. It works for our purposes. Yeah. Anything else? I think we can take a break here. Yeah. All right. Pro tip. What the hell is that? Yeah. I think things are looking good. Yeah, I don't know what else to say. We can probably polish a few more small things. Yeah, let's look into this here next change. And maybe this. And maybe this here as well. Maybe all of these, yeah. Get them to 0. And then I would say we conclude unassemblize for now and work on the next thing. Yeah. Because I don't see any bugs right now in here. I know that there will be bugs in here in the assembler. There will be some bugs here, but we don't see them right now, so we need more stuff to work with. So as things progress, I think we will see more bugs in here, and once we see those bugs, we can then work on these things and improve it. But overall, things are functional. It does what we needed to do right now, and I think that's all that matters right now. All right. It's fast. There's probably still room to improve things, especially on the disassemble function code. that is quite quite slow. But overall, I think things are quite fine. Yeah. Okay. Yeah. Yeah. Okay, see we have some spam posts here. Predator. Of course. Okay. Why can't 0 work without generals? It uses assets of generals. Models, audio, textures. All right, then I think we have everything sorted. Yeah. I'm very happy with the progress. Things work surprisingly well. We now have everything in place to do binary matching for Thyme. And I only care about Thyme. I don't care about other projects. As long as this works for Thyme, everything's good. If it doesn't work, we will fix it. Right? Yeah. Good. Then I will take a break here. And I wish you a great day or night. Until next time, goodbye.